This is a video on elasticity. We're going to talk about two types of elasticity computations. One, computing elasticity for a change, which is mostly what we focused on in Econ 202. And then another, we might want to calculate elasticity at a particular point, usually the equilibrium point. So the first way we talked about was elasticity of a change. And in general, we want to think about elasticity as the change in quantity demanded, or if it's supply elasticity, quantity supplied, when we have a change in price or income. So we have price elasticity, which is this percent change in quantity demanded over percent change in price. And if you're mathematically inclined to think about like slopes or gradients, remember that our demand equation, price is on the y-axis and quantity is on the x-axis. So we think about slope as rise over run. Our elasticity is kind of the inverse of that. So that's one way you can think about this if you want. Income elasticity, again, we have our percent change in quantity demanded over percent change in income. Cross price elasticity is a percent change in quantity demanded of some good X if we have a percent change in the price of a different good Y. And then the price elasticity supply percent change of a quantity supplied if we have a percent change in price. Right, so we calculate these usually by calculating the numerator and denominator separately. So we have something like our new quantity minus our old quantity over the average. For our percent change, we're going to use the midpoint formula. So how much was the total change divided by the average of the 2 points. And then we do the same thing for price or income if we're doing income elasticity. New minus old over the average. In the next video, I'll do some numeric examples of calculating both of these two types of elasticity. So hopefully that'll be helpful. This is just sort of the general case. We also want to consider calculating elasticity of demand or supply at a particular point, the equilibrium point. So we'll use the point elasticity formula. We're no longer using percent changes. Now we're just using total change in Q over change in P divided times P over Q. When we compute our equilibrium, we're computing P and Q, so we'll have those already to plug in. And then the challenge is just to figure out what is this change in Q when we have a change in P. So if we look at a demand curve, a supply curve would follow the same, but suppose we have the following demand curve. Quantity demanded is some constant A minus B times P. What this is telling us is that if we have a 1 unit change in P, quantity demanded decreases by B. So what's our change in quantity when we have a change in price? When we have a change in price, quantity changes by negative B. Right, so we can plug that in. We have negative B times our PQ. These will all be constants. This will give us a number. And then remember to always express that as a positive. Right, between 0 and 1 means inelastic. In absolute value, greater than 1 means elastic. And equal to 1 means unit elastic. So what do those look like on a graph? We have these ideas of perfect inelasticity and perfect elasticity. So if a good is perfectly inelastic, here we're talking about demand, but the same for supply. What it means is that the quantity does not change when we have a change in price. So I like to remember it just using I for inelastic, kind of looks like an I. And again, what it's saying is that if we have changes in price, quantity stays the same. So that's perfectly inelastic. And then perfectly elastic means that if we have any sort of change in price, we get an infinite change in quantity. In general, what this is just illustrating is that flatter demand or supply curves are more elastic. Steeper demand or supply curves are more inelastic. All right, as the price increases, if demand is inelastic, people have to buy the same quantity. So buy the same quantity at a higher price, expenditures increase. If the demand is elastic and price goes up, quantity demanded decreases by a whole bunch, and so total expenditures for the consumer will decrease. And then the opposite would be true for price decreases. If the price falls for an inelastic demand, people still buy the same amount, it costs less, they spend less, total expenditures falls. And for a price decrease, if demand is elastic, people buy a whole lot more of it, so their total expenditures go up. And finally, we've got this concept of short versus long run elasticity. And the idea here is that most goods, the elasticity tends to be higher in the long run as more substitutes enter the market, or maybe you just change your lifestyle around the availability. The exception is durable goods, like say a refrigerator. For those goods in the short run, your demand might be relatively elastic. If a new model comes out or something new or better, you get a good price, maybe you'll change your refrigerator. In the long run, though, you tend to need a set quantity, one refrigerator for most people, unless you have a very large house. Right, so in general, goods are more elastic in the long run. Durable goods, which need to be replaced in the long run, are more inelastic in the long run. Right, think about something like gasoline. Would gasoline be more inelastic in the short run or the long run? Well, in the long run, we tend to think of gasoline as having more substitutes. You could buy an electric car, start taking alternate forms of transportation instead of driving, things like that, move closer to your job. So we would think about that as being a good which is inelastic in the short run. You don't have many alternatives to filling up your car today. If you need to go somewhere in the long run, you have more alternatives, so more elastic. All right, in the next video, we'll do some problem solving.